Hello everyone, welcome to another video on Calculus 1. We are still looking at the precise definition of a limit. Today I have two examples which I'll prove using the precise definition of a limit without checking. So please do the checking. From the previous two videos, you must have seen how the checking is done to confirm that the choice of delta is indeed correct. So example number 1 here says use the precise definition of a limit to prove that the limit as x approaches minus 2 of 3 minus 2x is equal to 7. So the proof, we start by copying the question that has been given, and in step number 2 we state the precise definition of a limit, which in some cases is actually ignored. We just move straight into the proof, but for the sake of this video I would want to state the precise definition of a limit right from the start. It states that if the limit as x approaches a of f of x is equal to L, it means that for every epsilon greater than 0, there exists a delta which is greater than 0, such that if the absolute value of x minus a is less than delta but greater than 0, then the absolute value of the function minus the limit should be less than epsilon. Now let's put our limit into the precise definition of a limit. Therefore, the limit as x approaches minus 2 of 3 minus 2x is equal to 7 means for every epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus minus 2, the distance between x and minus 2, is less than delta but greater than 0, then the absolute value of our function, which is 3 minus 2x, minus the limit, should be less than epsilon. At this stage, we perform 4 steps. Step number 1 is to state what we're given. So in this case, we're given that epsilon is greater than 0 over here. And so we move on to step number 2, which is the choice of our delta. At this stage, we do not know what the right choice of delta is. Step number 3, we go to the assumption, and we assume that this condition here, which simplifies to absolute value of x plus 2 is less than delta but greater than 0. That's our assumption. Step number 4 is to notice, and we notice that this expression here simplifies. Absolute value of 3 minus 2x minus 7 simplifies to the absolute value of minus 2 minus 4, minus 2x minus 4. And if you factorize the expression minus 2x minus 4, you get minus 2 as your common factor, and then you have x plus 2, close brackets, like so. And if you go a step further, you're going to say that this is the same as the absolute value of minus 2 times the absolute value of x plus 2, like so. Moving forward, you will notice that this is the same as 2 times the absolute value of x plus 2. Now, if you go back to this step here, we say the absolute value of x plus 2 is less than delta. And so placing delta in this position here, placing delta in this position here, we get less than 2 delta. And setting 2 delta be equal to epsilon, and solving for delta, we get epsilon over 2. And if we take this value and substitute into that place there, you get an expression that is exactly 2 times epsilon over 2. And you cancel these 2, and therefore your answer is epsilon. So basically you are saying 2 delta is exactly equal to epsilon. And therefore it means that the whole expression there, the whole expression, this one here, is less than epsilon because that is epsilon. Now, please do the checking. But otherwise, if you'd want to move back to the second step, you would say, now we know the choice of our delta, and therefore our delta should be chosen as epsilon over 2. Epsilon over 2. So this then marks the end of the proof for example number 1, and I want to move to example number 2. Please do the checking. Example number 2, still linear functions, limits of linear functions. Example number 2 says, use the precise definition of a limit to prove that the limit as x approaches 2 of 4 minus 3x is equal to minus 2. As the tradition goes, we copy the given question as follows. And then step number, what I would call step number 1, or you would call it step number 2, if you consider this as your step number 1, is to state the precise definition of a limit, which says if the limit as x approaches a of f of x is equal to L, it means that for every epsilon greater than 0, there exists a delta which is greater than 0, such that if the absolute value of x minus a is less than delta but greater than 0, then the absolute value of our function minus the limit should be less than epsilon. Now, let's put this limit given here into the precise definition of a limit, and we get, therefore, the limit as x approaches 2 of 4 minus 3x equals minus 2 means for every epsilon greater than 0, there exists a delta which is greater than 0, such that if the absolute value of x minus 2 is less than delta but greater than 0, then the absolute value of our function 4 minus 3x minus the limit, which is minus 2, should be less than epsilon. Now we go to our 4-step procedure. Step number 1 is to state what we're given. As always, we're given that epsilon is greater than 0 over here, and indeed over here in the precise definition. Step number 2 is the choice of delta. And at this stage, we do not know what the choice of delta is. From the previous examples, you would recall that the choice of delta is made in step 4. Step 3 is the assumption step. So we assume, what do we assume? That this condition here holds. 0 is less than the absolute value of x minus 2. This must be less than delta. And step number 4, we notice. What do we notice? We notice that this expression here simplifies. So the absolute value of 4 minus 3x minus 2 simplifies to the absolute value of 4 minus 3x plus 2, which simplifies to 4 plus 2 is 6. The absolute value of minus 3x plus 6. If you factorize minus 3x plus 6, you get something like this. This is exactly equal to the absolute value of minus 3 as a common factor, or HCF, open brackets, x. If you divide minus 3 into positive 6, you get minus 2, like so, which translates into the absolute value of minus 3 times the absolute value of x minus 2. The absolute value of minus 3 is just 3, and then we have times the absolute value of x minus 2. Now, if you move back at this stage here, we say the absolute value of my x minus 2 is less than delta, bringing delta into this space, we get less than 3 delta. And if we set 3 delta to be equal to epsilon, and solving for delta, we get epsilon over 3. Taking this expression into that space there, we get exactly equal to 3 times epsilon over 3, and the 3's cancel, and your final answer is epsilon. This should be the end of our proof. It means that that's our choice of delta. And if you are interested, then you'd go back and say, in step number 2, now we're choosing delta to be equal to epsilon over 3. Please do the checking for these 2 examples that I've given you today. But otherwise, this is where our lesson ends for today. I'll see you in the next video.